to look at problem 16, and this is one of your homework problems, but I just want to point something out to you on this graph, and I didn't do a very good sketch, but you'll definitely want to look in your book on page 130. They ask you some questions about this rocket, but what they're showing you is a velocity graph. And you really have to be careful because think about the relationship between the velocity and the position of the rocket. We know that when the position of the rocket, so if you're looking at the position function, remember if the position function is increasing, that means that the velocity is positive, because remember the velocity is the slope of the position. So think about that here. The velocity is positive from t equals 0 to t equals 8. I didn't count this out on my graph, but I'm just looking now at page 130. So from t equals 0 to t equals 8, the velocity is positive, which tells me that my position function is increasing. So it can be really deceiving because when you look at a graph like this and you're being asked about the rocket, it's really tempting to say, oh, the rocket's going up, and then the rocket comes down. But we're looking at the velocity, not the position. So whenever the velocity is positive, the rocket is still going up. So the rocket is going up until this point right here. Then the rocket changes position because the velocity is 0. So the rocket changes position, and now the rocket starts to fall because the velocity is negative, so it's changed directions. Then obviously something happens here, even though the velocity is still negative, so the rocket's still going down, but something else must be happening at this point, and as you read through the problem, that will explain it. So you do need to be really careful when you are interpreting a graph. This is real typical on an AP exam as well. They like to give the velocity graph because, like I said before, they can ask you about the acceleration, and they can ask you about the position. As a matter of fact, let's talk about the acceleration. We know the acceleration is the derivative of velocity. So you're looking at the slope of this to talk about what's happening with the acceleration. So since the slope is positive, I know that it's accelerating. So my acceleration is positive here, and my velocity is positive, which also means it's speeding up. Here, because the slope of the velocity is negative, my acceleration is going to be negative. Even though the velocity is still positive, the acceleration is negative because it's sloped downward. So since the velocity is positive and the acceleration is negative, that tells me that the rocket is slowing down. So those are some things that you can get from that graph. And I think they ask you some of those questions. I probably have answered some of your homework questions. You'll just have to figure out which parts. Okay, go ahead and take a look at problem 23 in your textbook on page 131. I did draw the picture here, and it tells us this is the velocity graph of a particular particle moving along a coordinate line. So that's what we have here. Question A says, when does the body reverse direction? So we want to know when it changes direction. So what are the things you're looking for? Remember, it changes direction. It's moving here because the velocity is positive. Kind of like the rocket problem. The velocity is positive, so this tells me that the body is moving to the right, and then it changes directions because now the velocity is negative, so it's changed direction. So it changes directions when v of t equals 0. So that's going to be at t equals 2 seconds, and t equals 7, t equals 10. So that's where it's going to change directions because that's when the velocity is 0. Whether or not we consider that here, whether it's actually at 10, it's not changing directions because it may have stopped. It doesn't go from, in order to change directions, then my position has to go, here it goes from positive to negative, so I know it changes directions. Here it goes from negative to positive, so I know it changes directions. But here we don't know what's happening afterwards, so it's not, we wouldn't say it's changing directions even though the velocity is 0. Okay, in part B, when approximately is the body moving at a constant speed? Well, the speed is constant from t equals 3 to 6. It would be moving at a constant speed. And we can see that here because it's a constant. All right, and part C. Graph the body's speed for t between 0 and 10. So think about the relationship between the velocity and the speed. Remember that the speed is the absolute value of velocity. So I'm just going to switch colors, and I think I'm going to do it in black because I think I'm safe with that. So since this one was in green. So the only difference is going to be the part that's negative is going to get flipped over. So this point is going to get mapped up to this point mapped up to this point, and so my graph is going to end up going up, over across here, and down. The other portion of this is going to stay the same. That's still going to be the same. That's still going to be the same, and that would be the speed. Okay, so the negative portion gets flipped over the t-axis. And the next one says graph the acceleration where defined. So I'm going to pause this and kind of come back to that. So we'll hold on just a minute here. Okay, so I'm going to do a graph down here. I've got my acceleration set up here. So remember, the acceleration is the derivative of velocity. So I'm looking at the slope. So between 0 and 1, I have a slope of 3. So I'm going to have something that looks like this. And between 1 and 3, I have a slope of -3. Between 3 and 7, I have a slope of 0. By the way, this is an open circle. Between, sorry about that. I didn't want it to go that far. 6. Between 6 and 8, I have a slope of 3. And between 8 and 10, I have a slope of -3/2. Okay, so this would be my graph of acceleration, and you can see that it's not continuous. My acceleration graph is not, because there were some places where the velocity was not differentiable. Remember, anytime we have a corner, the graph is not differentiable at those places. Okay, I'm hoping that that is enough additional examples to get you through the homework problems that you need to have done, the ones I already assigned. I am not adding any additional homework problems. However, I do expect those to be done, or at least attempted with something done on each one. And if we are canceled tomorrow, check back, because I'm going to start in on the packet for trig, doing the derivatives of trig functions. So we'll start in on that tomorrow if we are canceled. So check back.